Hello students, today we will start a new topic, that is 2D page. That means a two-dimensional polyacrylamide gel electrophoresis. 2D page is the type of electrophoresis which is being carried out in two dimensions, A and B. We will discuss later on. And it is used for the separation of proteins having very much similar molecular weight or molecular mass. Okay? The 2D page, as it is apparent from this definition, it takes place in two dimension. It is a two-dimensional process. And that means it takes place in two steps. Okay, so that means that 2D page is a two-step process for the separation of proteins having very much similar molecular weight. And what are the two steps? The step one is isoelectric focusing. We have already discussed isoelectric focusing. What is isoelectric focusing? We have already discussed. Okay, that is this is the basis of this is the process of separation of protein molecules on the basis of their isoelectric point. As we know, isoelectric point of a protein is specific for that protein, and no two proteins have similar or isoelectric point. That means it is protein specific for a particular protein and vary for all the different type of proteins. Okay, so in the first step is the separation of protein on the basis of their isoelectric point, and the second one is the step 2 is the separation of protein on the basis of the molecular. Okay, so we will discuss here we will understand or discuss the process through this diagram. Here we have already discussed the isoelectric focusing. This is a step of gel of isoelectric focusing gel on a strip of plastic or glass. Okay, it contains the ampholytes. It contains ampholytes. Okay, making a pH gradient varying from 3 to 10. Here in the first step, we have remember the isoelectric focusing. These are the protein molecules having different charge, and the sample is dropped here, suppose in this point, and it is connected to the electrodes or electric supply, and these molecules of protein having different charge will start moving according to their charge on the pH gradient on the strip, and as a result when they start moving, they faces different pH molecule. That means if they gain or they lose their positive charge, and ultimately when they reach a point where their charge becomes 0, they will no longer be attracted by either anode or cathode, and they will stop migration, and they will stop at particular point. So at that point, suppose that this is the C protein, this means that this will stop here at this very point. At this very point it has no net charge. That means that charge on this protein is virtually 0 at this point. That means that this will stop at this point. And in this way, all the three type of proteins A, B, C will move different distance from this point according to their charges. Okay, and they will move differently and they stop migration at different point, and this way they will get separated from each other. So that means that this is the separation of protein according to their isoelectric point, and these proteins having very much similar molecular weight. Okay. In the first step, the movement is in this direction. Okay. In this direction, this is the one dimension. This is the one dimension. Okay. The movement is here. Okay. So in this way, these three proteins will get separated according to their isoelectric point. This is the isoelectric point of this C, this is for B, and this is the isoelectric point for A. At different, they will be having different isoelectric point, and they will stop migration at different points. That means that ultimately they will get separated from each other. Okay, this is the one directional separation movement. This takes place about 6 to 8 hours. Okay. After that, this strip having these separated proteins, we don't have their molecular mass right now, the knowledge of their molecular mass right now. In the end of isoelectric point, this strip is then incubated in SDS. Okay. In the SDS, they will get negative charge. The protein will get negative charge. That is the polyacrylamide gel electrophoresis. The process of polyacrylamide gel electrophoresis. In the next step, after about half an hour, this strip is incubated in sodium rhodocide sulfate, and after the incubation, this strip is put on another gel prepared for page, polyacrylamide gel. Okay. So this is the gel for page. Okay. Okay. So on this gel, this strip of IF gel is placed. That is on the top of the base gel, and the electric current is supplied. The protein start migration from this step to that is the page. Okay, and during electrophoresis, the protein molecules start migrating in this direction. Okay, and at the end they will be here supposedly. After that electrophoresis, the protein will be stable. Okay, we have already discussed about the staining and all that things. Okay, so after staining, we will get the bands of protein. These are the bands of protein. Okay, so that means these proteins which are having very much similar molecular mass or weight will get separated and forming different bands in the after the page. Okay, and by staining we can study the nature of this protein. Okay, after electrophoresis. So remember that in the first step the movement is in this direction. Okay. Okay, this is the first dimension, and in the second stage the movement is in this direction. So that means in this direction and suppose in this direction. So this is the two-dimensional movement. So by the method of this two-dimensional method, we can separate the protein having very much similar molecular weight. Okay, in the first step, the first step is isoelectric focusing. That is the migration based upon the difference in their isoelectric point, and in the second step, the migration takes place on the basis of the difference in the molecular weight of this protein. Okay, so this is the two-dimensional gel electrophoresis. We will in the next class we will discuss about the use of this two things. Okay, thank you.